Okay, we got a few more questions to go over, and look at there, they're starting to even out. We had 26 questions, and now we got 5. So what's starting to happen is you're starting to finish those first 3 sections. Of course, we got the overachiever going into 1.1, and she's not supposed to be there, but that's okay. Let's get us started into today's class, okay? So let's go over the rationalizing review, see if that's one that we need to. That is a test question, but I'd much rather see it in the denominator. So I'm going to do it with the denominator and the numerator. So we're going to do 2 questions on this one. So make sure you write this one down, because this is a test question, and I'm going to show you how I'd like to see it on the test. So what's the C word that we're going to use here? C-O-N. Conjugate. Good. You're the one that listened. All right. So go ahead and write down this one while I get the whiteboard. I thought the whiteboard was already up. Hold on. Dang old whiteboard. There we go.
I'm sorry.
No, you're good. I just don't need it.
Yeah.
There we go.
Sorry.
So the question says rationalize the numerator. And there will be a few times when you get into calculus that you will rationalize the numerator, but 90% of the time you're going to rationalize the denominator because you're doing the limits and you can't divide by 0. So you have to rationalize the denominator so you won't have 0 in the denominator. So 90% of the time they're going to ask you to rationalize the numerator. But in this case, square root of r plus the square root of 3 over 9. And I'm going to take my handy dandy blue pen, because I don't like red, and I'm going to multiply by the conjugate, r minus square root of 3 over square root of r minus square root of 3. Now, of course, that gives us shortcut number 3 on the top. And it will always give you shortcut number 3. That's why you multiply by the conjugate. So I'm going to take my green pen, and I'm going to circle this. And this is called shortcut number 3, which is a plus b times a minus b is equal to parentheses squared minus parentheses squared over, thank you, over 9 times square root of r minus square root of 3. Do we care about the denominator here? No.
No.
Because the instructions tell you to rationalize the what? The numerator. So we care less about the denominator. So finish it out. Stick in that square root of r in that parentheses and stick in the square root of 3 and then do your pre-algebra or your algebra 1. Or you could just quit, throw down the pencil. Make it pop against the notebook paper. Y'all done that before, right? Get mad and cuss everybody out and throw your pencil down.
That's good. We should do that all the time. I do have mine. It's tick.
Square root of r, square root of 3. Take my handy dandy red pen, and what happens to the square root and the root and the square?
Choose a way.
Another radical.
So what's in the numerator?
R minus
3 over 9 times square root of r, square root of 3. Now, we just did the problem that was asked, okay? And that's your answer in the green box over there. Now, turn it around and put it in the denominator, and then you're going to have a test question. So that's the one I'm going to give you on the test, denominator. So we're going to turn it around, and I'm going to put 9 over the square root of r plus the square root of 3. Dang old whiteboard. I done forgot it. 9 over the square root of r plus the square root of 3. Is that it? Okay, so this is a test question. If I could give you one like this on the test, I'm going to give it to you. So I want to multiply by the conjugate of the square root of r minus 3 plus 3. So that's going to be multiplied by the square root of r minus 3 over the square root of r minus square root of 3. Yeah, is it me or is Hollywood putting out a bunch of sorry movies right now?
The green, what is that called? There's a bunch of them they put out.
I think they are. I think they need to quit telling everybody how to live and how to think, and I think they need to stick to what they're good at, and that's what? Making movies.
Some guy just throwing money at like every movie in hopes of like they make some money back.
Kind of like the music they play on. They call it country music. They just go out there and put some words together, and that's supposed to be country music. I think they need to quit throwing money at the theater and thinking it's going to, because they're putting out some real bad movies right now.
Did you go see Glass?
No, I saw the first movie, Breakable or whatever, Breakable, and then I saw
Unbreakable.
What's the movie where the guy was locked up, personalities? Yeah, and I'm like, okay, it wasn't that good to me, but some of y'all like it. Some people like it.
I haven't seen it. I watched like YouTube.
I really thought, what was the movie about the personalities? Split. That was hyped up, and I thought it was going to be all this good, and it was like a letdown to me.
I didn't watch it.
So I don't know. What do y'all think about it?
I haven't seen it.
You haven't seen it? And Samuel Jackson is a great actor. I love Samuel Jackson. I love it when he plays a southern person, especially in Black State Nun. I love that movie.
Like
And when he plays in that movie where his daughter gets killed by the white supremacist, Mississippi Burning, I think it's called, or Mississippi something with Matthew McConaughey. I can't remember what it is. But anyway, and Sandra Bullock, of course. But anyway, make a long story short, I love him, but in that movie, I didn't understand it. So, and now they got all three of them together. Is that some kind of comic strip or something?
It's supposed to be some kind of, yeah, I think so. I'm not sure.
So it's a real comic strip?
I think so. Like, that's the way I've heard about it. Like, it's supposed to be a superhero thing. But I don't know if it's actual comic.
So did you see it?
No, I just watched, like, YouTube videos on it to decide if I was interested enough to see it.
Has anybody seen it yet? Okay, so it must suck because nobody goes to see it. I don't know. I know it's on Fire Stick, and I haven't even watched it on Fire Stick because I don't really care nothing about it. But,
Fire Stick.
So who knows?
Have you seen that Gary Busey commercial?
Gary Busey commercial?
Yeah, he's got the Fire Stick. He's like,
what does he do now? That guy's crazy. What does he do with the Fire Stick?
He's spaced out so far. He's just sitting there talking to it. Find me a Gary Busey film.
I'll have to look at that one. You know, his brain is fried. Anyway, all right, let's talk about math. So here we go. So I'm going to multiply this, and that gives me the numerator, which I don't care about because I care about the denominator. So square root of r minus square root of 3. And this gives us shortcut number 3, which means that I'm going to rewrite this as the square root squared minus the square root squared, a squared minus b squared, square root of r, square root of 3. Take our handy dandy red pen. And I know this seems repetitious, but this is not hard. But the reason people don't do these problems is they've never been exposed to them. They've never been taught how to do them. And if you don't know the shortcuts, then you're going to suck at it. So 9 square root of r minus square root of 3 over r minus 3. And that's how you rationalize the denominator. So that right there is a test question. Y'all feel good about yourself?
Oh, yeah.
Where's my gallon water bottles? Where are they at? Don't even bring in gallon water bottles.
Oh, there.
Sunglasses.
Well, y'all just aren't in the in crowd. What, where's your milk jug? You talking about your milk jug?
Oh, no.
Oh, okay. I thought y'all had a milk jug. I'm sorry.
Down.
Talking about
See my
what?
brother. Yes, you know what?
I have to do the almond coconut. It's better than just almond milk. The almond milk is too. I like almond coconut milk. Put a little vodka in there, a little bit of White Russian. Yeah, it works out real good. All right, so that's that question. So now we got to get to people that don't listen. Go into 1.1 overachievers. Oh, I'm sorry, Miss Shuttleworth's question. Oh, how did you send 4 questions at one time, or did it do it automatically?
It just did it automatically, I think.
Good God, how many did you send? Like 15?
It's only 4.
Okay, well, we got to go into these. Okay, we're not ready to go into these yet because these are exponentials, and we're going to talk about exponentials. And that is now this right here, okay, I want to give everybody, this is a perfect example right here of a quadratic formula. There's your quadratic formula right there. So write that down. Write that question down. That is a test question. But when do you use the quadratic formula? When you're given a question like this. Okay? Make sure you can do that with the quadratic formula. And make sure you can graph it. Now, I'm going to grab this question out of all your questions because this question is a question that you should be able to do, period, because you've all had algebra. So get your graphing calculators out. I'll write it at the top. I'm sorry. I should have done that because some of y'all can't see it. So hold on. The question revolves around f of x is equal to 0.638 x squared plus 6.671x plus 627.619. Okay? So 0.638 x squared plus 6.671x plus 627.619. Now, you can do this with the quadratic formula, but what I would suggest is to graph it with your calculator and find everything you need to with the graph. So we're going to do that. Go ahead and be working on it because I need to pull up the calculator and type it in. That'll take me forever because I suck at the calculator because I don't like using it. But I'll do it for y'all. I'll sacrifice for y'all. Make sure you got that written down because I'm not going to be able to see it here in just a second. Well, I may be able to. Let me see if I can pull this up. Go ahead and be playing on your calculator. Some of y'all could twirl it around like a basketball on your daggum finger. Dang old calculator drill team in high school. Y is equal to, let me see if I can pull it back up. And there we go. Oh yeah, we could with peanut OIL now. So that's 0.638 x squared plus 6.671x. Make sure I type it in right. Plus 627.619. Somebody tell me that's mathematically gifted, can foresee the future. What's the y-intercept?
627.619.
Y'all are gifted, okay? 627. How do you get that? Well, plug in 0 for x. You get 627.619. That is your x-intercept. So you know your window, the y is going to have to go up to at least 700 or 800, right? Y'all know that, right? Because you're not going to be able to see it. All right, so let's go ahead and hit graph, and you're not going to be able to see it unless it puts it in focus, and I doubt it's going to. It doesn't. So we go to window, and I'm just going to go ahead and change the y max to 800. Very shallow. But what I'm going to do now, this is a trick I learned in the war. I'm going to zoom out. Some people ask, when did you use that in the war? I think there's 2 or 3 things they need to add to y'all's high school curriculum. One is sense of humor 101. And then the other is finance math 101. But that's just me. Now, I don't even know what the question's asking, but I guarantee you it's going to ask you for the x-intercepts, and it's going to ask you for the vertex. What is the x-intercepts? That's where it crosses the what? So what can you tell me about this parabola? It has no x-intercept, so you know it does not cross the x-axis. Okay? Second thing they're going to ask for is they're going to ask for the vertex. The vertex is always your highest or your what? Lowest point, depending on if you're working with a mountaintop or a bowl. In this case, we're dealing with a what? A bowl. So it's your lowest point. So how do you find that lowest point with your calculator? You hit second trace, which is calculate, second trace, and you find the what?
Minimum.
Bowl is minimum. And you say, okay, the left-hand side is right about here. And the right-hand side is right about here. And that's just to narrow down the spectrum to look for the calculator to look for. You don't have to do that. You can just hit enter, and it'll still find it. And I'm going to put the vertex right about there, and let's see what it gives us. And there is your lowest point. Write that down. Negative 5.228 and 610.18. So that is your lowest point. Now, they may not ask for that. It says, what is the expected value to be at 2022? Okay, now they're asking you to plug in a number. All right, so let me move this out of the way. It says population actually since the year in 2000 can be modeled as X years since what?
2000.
2000. So X here is going to be what?
22.
22. Now you can do this 2 ways. One is you can plug and chug. The other is go to the handy dandy calculator and go to table. Second table. And find 22. It's a miracle. There you go. 22 comes out to be 1083.2. It is right there, 1083.2. They rounded it up. When you plug the number in, now you can change that. Go to table set. And I don't know, let's see, you can actually take it to, I think, 0.0001, like that. Hit enter. And now hit second table. And find, what is it, 22? It's going to take longer. So you go down to 22, and eventually it'll give you the number, or you can just plug in 22. Or you can go to trace and find 22. We'll do that also. You see, that's going to take forever. And I'm just on. Or you can go to second, table set, and I want to ask for my independent variable. So you go down to ask, hit enter, and then you hit second table, and you can hit that blame thing. Oh my Lord. Damn Russians.
Fine question. Honestly, I'm like horrible at calculating.
Now type in 22 and hit enter. So you can do it that way, or you can go to graph and hit trace and go until you get 22. But it's not going to give you an accurate unless it's right on it. See? That's going to be hard, and you can blow it up. You can go in there and hit zoom in. I'm just showing you everything because I want you to pick what you want, okay? And there is, and I'm going to try to hit trace again, and maybe I need to go to the left a little bit. There's 21.9, so I still need to pull it in, zoom in, enter, and now I'm going to try to find zoom, trace. That's as close as I can get it. Now, you can keep blowing it up and you can get 22.0001 or something like that. But that's 1083.91, 1083.17, so eventually you'll get it if you blow it up. So that's 3 or 4 ways to do this question. Is this a test question? Yes. Make sure you can find whatever you need to find on this question. It says B, when is Alaska's population expected to reach 750,000? Well, you need to find 7500. You need to find 7,500. Now, you can ask for the independent variable. You can go in there and ask for that. Second table set. And go in here and ask for, I'm going to put auto there, and ask here. I ain't never got this to work right, but I'm going to try to do it now. And see, I thought, hold on, second table set, change this to 1 again. Delete, there, graph, ah shoot, table. See, I ain't never got it to work right. What is 7,500? See, I don't know why it won't. There it is. Dang, I did get it to work. But it says 9.56, 750,000. So maybe I need to put in 750,000. I don't know how it's gonna. I don't know how that works. Let me go to Zoom format and put ask. I don't think ask on that's gonna work. Let me try that. Second table. And type in 75 0 0 0 0. See, it's not working. Another way you can do it, I wouldn't trust that. Go to the graph and go back to zoom out. Oh, we got to zoom out like 5 times. Zoom out. And this is just a calculator drill, so just zoom out several times. Or if you want to do window, change that back to, change this to 0. Enter, graph. And now type in y is equal to 75,000 or 7,500. It'd be 750,000. Let's do 700,000. I don't think that's going to be right. Enter, graph. It should be 7,500. Yeah, 7,500. Let me redo that. Y is equal to 7,500. 7,500. Delete. There we go. Graph. And eventually it'll show the vertical line or the horizontal line, which I'm going to zoom out again. And you just got to keep playing with it. And of course, if you learn a faster way of doing it, that's great. Tell me about it. And eventually you'll see where the 7,500 crosses. I don't see it yet. There's 13.6. So I got to zoom out some more. And you can go to the window and type in 8,000 or 8,000 or whatever. You can do that. There's several different ways to do it. So there we go. And now we find the intersection point. How do you find the intersection point? Well, you hit second, trace, and you go down and hit intersect. Now again, I don't know how many of you know this, so I'm just going through it. Hit first curve, second curve, and then where is my guess? Well, it's going to hit somewhere right in there. And there is 98.69. Okay? Now the reason it's different is I think theirs is set up on a different scale because let me see what they've got the question. It says population actual and predicted 2000 can be modeled as. Okay, well evidently either I have something wrong or mine's coming up a little bit different. Let me type in 75,000. If I type in 75,000, 75,000 up here, it ain't gonna be 9.56. So I'm doing something wrong. Let me check my graph. Hold on a second. Make sure I got it typed in right. 0.638 x squared, right? Plus 6.671 x, 0.627.61.
Wouldn't it be
Again, what?
Wouldn't it just be 750 or
750. Thank you. I knew there was something I was doing wrong. I don't know why. They're talking about keyboard, Hubert. Don't use the keyboard. Let me take that out. Thank you for your help on that one. All right, now try it. Let's see what that gives us.
750,000, Hubert.
So it wants 750,000? 750,000 is going to be way out here. So I think let's try 750 and see what it gives us. The reason is because they're talking about millions or talking about whatever, and they've neglected to put that in the problem. And then when you put it in the calculator, I'm trying to get there. Just hold on a minute. Zoom in. Calculators. There we go. Y'all see why I don't use calculator very much. Let me zoom in right there. Let's see where 750 is going to be right there. Now hit second, trace, intersect, enter, and there, and then guess is going to be right in there maybe. There it is, 9.576. There it is, so 750. And I guess, it says somewhere in the question, there should be something about millions of people or 1,000 right there.
It says 1,000 people underneath.
1,000 right there. So there it is right there above. See where it says 1,000? I didn't see that. That's it. So it'd be nice if they just left that off. Then you'd understand it a whole lot better. But anyway, so you type in 750, and that right here with the little cross, oh my gosh, that's a cross. Oh my God, I'm offended. 1,000 people. So 750 would represent 750,000. Did you get that, Miss Shuttleworth? Did you know that, or did you, like me, just now see that?
I let you just now see that.
Okay.
Yeah, that would explain why my
And I just now saw it. What it was, the upside down cross, I wanted to stay away from that. Or not the upside down cross, the cross. Now I'm being a Satanist. Oh my God. Are y'all offended yet?
Yeah.
Okay, good.
Yeah, I'm going to the department head.
Go to the Department of Offense, okay?
That too.
Call the police.
Go to that Indian guy, the Native American with the drum. Boom, 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 boom. We have lost our damn minds. He got mad because there was a person wearing a red hat.
My friend was there when that happened.
Hey, I have a question.
And then the media turned it around and made it like those guys from... Yes, go ahead and ask a question. I'm sorry.
How do you figure out the month? I understand the year, but how do you find July?
Okay, I'm looking for that question. Where is the question?
And part B.
Oh, I'm sorry. years after blah, 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 etc. This is occurrence to July of 2010. Okay, look at the number of years. X is the number of years. You can't have 9.5 years. Well, I guess you could have 9.5 years. So let's say it's 9.6, okay? They may be saying 10, or 9.6 is the 6th month, okay, whatever. But what's the year? 9 added on to 2009 is 10. That's what they're doing. They're saying 9.5 is equal to what? 10. 10 years. 10 years from what? 2000 is what? 2010. How they're getting July?
Okay, is that a test question? Do we need to know how to get the
I
month?
have no idea how they got July. Can anybody elaborate on how they got July?
Yeah, they got July. They multiplied the 0.56 or to round it up. They multiplied just the 0.56 part
Okay.
by 12 to find what month it was.
That's ridiculous. No, that's ridiculous. I would never ask that question. I don't think you're ever going to be asked that question. Yeah, can you tell me what month it's going to be? Really? No, they're going to just ask the 2010. But that's a good question. But they're doing the 9.56. Did they round it up to 9.6?
Yeah.
Or do you have to leave it 9.576 and that'll give you July, the 6th month? I guess they're saying the 6th month or the 7th month. What is July? 6th or 7th?
It'd be July of 2009.
I have no idea how that's to me ridiculous.
Extra year.
What do they multiply? 9.6 or 9.576?
9.6, they're just saying 9 years and 6 months.
Well, 9 years would be 2009.
It's like, yeah, they're rounding up 9.57 to 10.6.
Now, what I would suggest, and this is to you that asked that question, what's your name?
Marina.
Last name?
Youssef.
Youssef. Miss Youssef, if you're in a statistical type question, they're not going to ask you the month. They're going to ask you the year. You round this to 10, write that number right there to 10, and you add the 10 to what? 2000. The year 2010, your population is going to be 750,000. That is ridiculous to get it down to a month because, no, I'm not even going there.
My 109 teacher used to ask us down to the minute.
Yeah.
That's not real world.
Mr. John.
That's fantasy land. You know, unicorns, cotton candy clouds, and candy mountains. Where some of those people in Hollywood live.
It's a fun board game. It is fun.
Save the straws. Get rid of the receipts. But we got the #1 homeless population and drug population in the United States. But we're going to get rid of those straws and we're going to get rid of those paper receipts. I like those people in Chicago trying to change gun laws like it's hell the last 20 years.
Also, they just banned plastic bags in New York or something.
Okay, now let's go. I'm going to go to the whiteboard here. We're going to get off the questions right quick, Ms. Shuttleworth, because I don't like you and I don't want to go over your questions. But I'm going to go over the questions of exponential laws and logarithms. We're going to go over that right quick. Now, all of us know our exponential laws. We know that our laws of exponents are as follows. X to the n, okay? We're writing all over the place now, and I'm not even touching the... Okay, let's try this again. X to the n times x to the m is equal to x to the n plus n. That is the product rule. The quotient rule, x to the n divided by x to the m is equal to x to the n minus m. And what rule is that? The quotient rule. The power rule, x to the n times x to the m is equal to x to the n times m. which is the what? The power rule.
Power.
Now, with exponents, logarithms are glorified what? Glorified exponents. Product rule, log of m, I'm sorry, not base m, log of m, and natural log also, it doesn't matter which one you use, times n is equal to the natural log of m plus what? Natural log of m plus the natural log of n. Meaning if you are multiplying, this is base 10 or base E would be natural log, okay? Natural log of m plus the natural log of, or log of n. Same thing with the quotient rule. If you have log of m divided by n, that's equal to log of m minus log of n. And if you have log of x to the 5th power, that's going to be 5 log of x. Okay? So hopefully most of y'all remember this kind of review. You've got to remember the basics of the natural log also. All right, we're going to go into that because the first you got to remember your basic laws, and there's two more laws, and I'm just going to show you right quick. X to the negative 1 over 1 is equal to 1 over x to the first, meaning that you flip, they become positive. So that's that. And then you've got, that's the inverse rule. And then the inverse power rule is where you have x to the 5th over x, or y to the 3rd raised to the negative 5th power is equal to y to the 3rd over x to the 5th raised to the what? To the 5th power. Remember, these two right here are basically to address the negative exponent. They're not really for, they're not really for calculating or simplifying. They're just to get rid of the negative exponent. So I don't, these are kind of like secondary. These right here are the ones you need to remember. Okay? Because they're the ones that help you simplify. All right? So, I want to go back. We covered this, the basic exponentials. That's a review. That's pre-algebra, algebra 1. And then we move over here, and this is more like algebra 2, right here, where you get the logarithms. And then we talk about natural log, and then we go into exponentials. So you need to know the difference between the two. So next I want to go into from logarithms to natural log. And you also got to know your basics, your basic laws, and we'll go into that. Okay? So, log base 10 is what we get in the calculator. Log in the calculator, log base 10 is the LOG button on your calculator. Your calculator can only calculate two logs. What are they? Log base 10 and log base what?
E.
E. And log base E is what we call the what?
Natural log.
Natural log. You take your pick which one you'd like to use. The properties are all the same. One is ln, the other one is log. I like log because I think it's easier to work with in calculus. But you get into differential equations, the natural log is easier to work with because you raise everything to the e power and it takes out the natural log. We won't go there yet. All right? Now, the one good thing about the natural log that feeds into the exponentials, f of x is equal to any number, I'm just going to put a number to the n power. Okay? All of these are in the first what? Quadrant. Why? Well, because you want to stay in the first quadrant, you can't take the log of what? A negative number. And if you do put a negative number in the end, then you're going to turn it over and it's going to become a positive. So, you're going to be dealing with the first quadrant. All right? Why are you dealing with the first quadrant? What do all of you have in common? You're in what major?
Business.
Business. Why do you want to stay in the first quadrant? Because positive means what? The other P word in business. Profit. If you're not in the first quadrant, you suck as a business person, and you're going to end up quitting and living in a ditch somewhere. Okay? Because you are not giving good advice to people if they're in the other quadrants. The other quadrants have what in them?
Negative.
Negative, which means you're going to live in a ditch. So you want to stay in the positive quadrant. And the positive quadrant is going to deal with these guys right here. So in business, you're going to be dealing with logarithms, and you're going to be dealing with exponentials. A good exponential is like this. F of x, show you what it looks like, 2 to the x power. That's an example of an exponential. Okay? Now, before we get to the exponentials, you've got to remember the logarithmic basic properties, and some of y'all may have forgotten those. So, it's a lot of work. You have to go to Google. You know what irritates me? I'm a Facebook person, okay? I tried Twitter, and I tried Instagram. I tried them all, and they suck, okay? I don't like Instagram, and I tried. I gave it the good old college try. Twitter, I don't understand Twitter. I mean, you can do the same thing on Facebook. Why? You can do more on Facebook. Why do you do Twitter? I don't understand Twitter. I tried. I can't stand when people ask DA questions on Facebook. Okay? One of the greatest things in the world is Google. If I don't understand something on a movie, I Google it. If I don't know what a word is, somebody used a big word around me, I Google it. Okay? Because I'm one of these people that believe in learn something what? Every day. Yeah, learn something new. These people get on Facebook. Does anybody know of a person that I can get to lay brick at my house? Look it up on Google. It's called Near Me. Y'all know the Near Me function? And y'all can even ask. But why do people get on Facebook and ask these dumb questions? I'm done. Don't ask me why. I'm on medication for that. But anyway, you can get on Google. That's why I got on it, because you can go to Google, because Google gives you everything. No, I'm going to go to Facebook. Go to Facebook and ask what the natural log of E is, or what log of E is, and see if you can find somebody to answer you. Oh. So type in log properties. This is real tough. Some of y'all won't be able to do it. Look at there. It's a miracle. Hit images. Oh, look at there. And there's a good one right there. Click on that. And make it dadgum 20 times bigger. We, of course, take it into Paint or Print or whatever. All right, let's look at those. You need to write those down. I mean, don't write them down right now. You can Google it or whatever. But there's the product rule. There's the quotient rule. There's the power rule. There's the change base formula. Okay, write that down. Because all this should be reviewed. So what I want to show you that you may have forgotten, and that's these right here. These bottom ones down here. Write them down. You don't have to write down all of them. Just go down to that natural log of A to the R is equal to R. You can write down the other ones if you want to, but we're not going to be using those very much. Those first three. Now those first three right there are very important. And I'm going to show you the natural log properties in just a minute, because you're going to see the natural log properties, follow the same. This one helps you out a lot. The natural log base A of A is equal to A to the R. That one helps you out a lot, so highlight that one. Well, like I say, you don't have to write all them other ones. The last four, you don't have to write those. Just write down the first three. And then right after you go to that one, I want you to look up natural log properties. Look up natural log properties. Look over there. Natural log properties. Images. And you can print those out too whenever you find one you like. I like to see the natural log. That's not what I'm, just hold on a minute.
Maybe we should check Facebook.
Yeah, maybe I should go ask them. I can't think of a good question right now, but I get on Facebook several times a day because I'm a Facebook person. And there'll be some, and then you got the people that want you to know what they're doing. Like I know this chick, she's getting married, and she's one of these people that go freaking crazy when she got asked to marry her. So she goes on Facebook every day. Can anybody tell me where I can get bow ties? Can anybody tell me where I can find a place to make a fountain of champagne? Can anybody tell me where to get? People know you're getting married, girl. Shut up. Go to Google. Near me.
Get your essential oils and so.
Y'all know what I'm talking about, right? Y'all know the girls I'm talking about. There's two types of girls. There's the two that get on my nerves. There's the one that wants everybody to know they're getting married, okay? And then there's the one that wants everybody to know they're pregnant. And they'll start coming to class, and they'll bring this big old glass of water, or this real weird bottle of water, and they want you to ask them, "Why are you drinking that water?" "Oh, because I'm pregnant." And it's like they just found out they're pregnant like 15 months. Before they start showing, and they want everybody to know they're pregnant. Oh, God. People get on my nerves. All right, I'm sorry. I'll be all right. I'm trying to find it, but I can't find what I'm looking for. Okay, now, one of the reasons I use natural log is because, not natural log, the reason I use LOG is because of this, because of that one I showed you, the one that I told you I liked, the one, number 3. Let me get back to it. Well, now I can't find the dadgum property. But anyway, it's the one that says the natural log base E of E is equal to the exponent. That's the one I wanted you to find, but I can't find it now. This still says natural log. Hold on. There it is. Okay, that one right there. Because I'll show you why that one's important. Take my whiteboard. Let me go over to another screen, and let's say I get the natural log of E, and you get that on a standardized test. All right, so natural log of E to the 4th power. All right, the first thing you want to do is change it to LOG. Why? Because LOG, natural log, is LOG base E, right? So now we got LOG base E of E to the 4th power. And what does that property tell you if these two match? The answer is what? 4. Okay, so that's why you need to learn those properties, especially that third one. Okay? And it helps when we get into taking the derivative or the antiderivative of the natural log or the LOG. That helps. All right? Now, make sure when you're talking about, and I'm going to make a transition before we get to the exponentials, we got to go over another review process. And the other review is your shifts. Okay, remember your shifts, remember your parent graphs. If you had me for 109, you remember your parent graphs?
Yes, sir.
Okay, you got them with you? You need to have them. Okay, the parent graphs. I'm going to give you an example of what I gave my class in 109. This is a piece of notebook paper. It's divided into its landscape. It's divided into 8 or 10 sections. You might want to do this. If you wasn't in my 109 class, you might want to do this. All right, your first one is x to the 1st power. X to the 1st power always is a straight what?
Line.
Line. That's a linear equation. X to the 2nd is always what?
A parabola.
Good job. You had a good teacher in 109. X to the 3rd power is always what? The swerve.
Eggy thing.
X to the 4th power is what? It's another parabola. But what happens as you get x to the 4th, x to the 6th, x to the 8th, x to the 10th? Your quartic function starts to square off at the bottom. Instead of looking like a U, it starts to look like a bucket. Okay, it starts to get wider at the bottom. So your parabola starts to square up at the bottom, like that. The higher your exponent. Of course, I've already done this in 109. Did y'all the other 109 teachers show you this? Nobody's going to say yours did. I was your 109 teacher. Who didn't have me for 109? Okay, did your teacher show you this?
No.
See what I'm saying? All right, so x to the 5th, 7th, 9th, so on, it's going to be a little bit more square than the curve. So you got the end behavior here, but this down here starts to square off versus not squared right there. And then you got your what? Somebody give me one that I forgot. Does anybody remember from my 109 class?
Absolute value.
Absolute value. That's absolute vodka. Vodka and value start with a what?
V.
V. So absolute value of X, that's going to look like a V. Absolute value, absolute vodka. So you alcoholics. All right, next. Square root of X. What does that look like? Looks like the swoosh. And then we got the volcano and the half a volcano. 1 over X. That's the half a volcano. And then what is 1 over X squared? That's the full volcano. And then, of course, you can add now your X function, or your something to the X power, 2 to the X, 4 to the X, whatever. What does that look like? Well, it's going to be in the first quadrant, but somebody, let me take my handy dandy calculator, and let's just do 2 to the X in your calculator. Where in the heck is he going with this? Well, just give me time. Y'all were supposed to already know this, but now you got to do it in your calculator, and you got to do each one of these because somebody didn't do their job. Anyway, I'm going to go y is equal to 2 to the X power. Everybody with me? And hit delete, delete, delete. And go down here and hit delete, delete, delete. And hit graph. And hit zoom standard. Zoom, zoom, hello. Zoom standard is 6. Okay, well, it's not in the, it's close, but where's most of it? Most of it's in the first what? Quadrant. And it's going to look something like this. Okay? Now, what does the vertical and horizontal shifts do to all this? Well, let's take, for instance, x squared. And we talked about this in 109 until y'all were basically what? Sick of it. All right, let's take f of x squared, or f of x is equal to x squared plus 4x plus 8. I don't know what it looks like. But anyway, you got to do completing the square, and you get it into this form. X squared plus 4x plus blank is equal to negative 8 plus blank. And you get half of 4 is 2. 2 squared is 4. 4. X plus 2 quantity squared is equal to negative 4. And you know you don't have any x-intercepts. The vertex is what? The vertex is negative 2, 1, 2, and positive 4, 1, 2, 3, 4. So you know you don't have x-intercepts, so it looks like this. So my vertical shift is 2 to the left, and my horizontal shift is what? 4, should be 4, yeah, 4 up. I just take the opposite of both, okay? So 4 up, so it's in this. So I had a vertical or horizontal shift of 2 to the left and 4 up. Now, does that apply to the rest of these? Yes. Let's take absolute value. Let's say f of x is equal to absolute value of x plus 2 minus 3. So that means I've got a vertical shift of 2 to the left, 1, 2, and 3 what? Down. 1, 2, 3. So now my, okay, 109 people, everybody should know that. Everybody should know vertical and horizontal shifts. So now if I have a function right here that we're learning about, and I have a 2 to the x plus 2, I know that 2 to the x plus 2 is going to change things. So let's do that. Let's change 2 to the x plus 2 in our calculator. So let's go down to our calculator. I got to find it. So here we go. I'm going to take my y is equal. I'm going to go down here and change this one to a dark color. And I'm going to write 2 exponential, parentheses, x plus what? Let's make it an x minus 2. So x minus 2. What would x minus 2 tell you, 109 students? It's going to be a horizontal shift of 2 to the what?
Left. I mean to the right. Wow, what is happening? To the right.
And look at there. Look what it did. It moved 2 to the what? To the right. Well, here, what about if it's a vertical shift? Well, then it'd be x plus 2 or 2 to the x, and then it'd have plus 4, or that'd be a vertical shift. What did I tell my 109 students? What do you know about the vertical and horizontal shift? The horizontal shift is always attached to the what?
The x-axis.
To the x, not the x-axis, the x. And your vertical shift is always detached from your x. Okay? When I wrote that 2 to the x plus 2, y is equal to 2 to the x plus 2. That 2, that positive 2, or minus 2, sorry, that minus 2 is attached to the what?
X.
To the x. But what if I was to put out here plus 7? That 7 is not attached to the x. That 7 is attached to the function 2 to the x plus 2. So that 7 is a vertical shift. Now all this should be reviewed for 109 students. If it's not reviewed, then you didn't get your money's worth. Okay? Because you got to know this stuff. So now, when I add a 7 to it, and you should be doing this on your calculator also, hit over here, go y is equal. And now I'm going to go down here, and I'm going to make it dashed. I guarantee you somebody's going, I don't know if you do that. There's my dashed. And I'm going to change it to 2. Parentheses, or, there we go, parentheses, x minus 2. There, the 2 is attached to the x. Now I'm going to go plus what? 7. And what is that 7? A vertical shift of 7 what? Up or down? You only got 2 ways. Up. When it's in that form right there, you just use whatever it is. The negative is always opposite. What's attached to the 2, that vertical shift is always opposite. That'll be 7 up. So hit graph, and look at there. It's a miracle. 7 up. Now, if you did not get this material, you need to go back over it. All right? Because we're going to be going over in 1.1 and 1.2 and probably 1.3. We're going to be doing nothing but logarithms and exponents and all that. So you need to know. Now, the exponentials, so you're going to put right here, you're going to put that it looks like that. And now you've got, now you've got the parent graphs, the vertical shift, horizontal shift. You know what these things are going to be doing. Well, what about the number in front of it? Well, what does the number in front of it mean? Well, the number in front of it, whether you have a 5 or 7. Remember, we talked about it in 109. F of x is equal to a x plus h, quantity squared, or absolute value, or to the 3rd power, plus k. We know this is our vertical shift. We know this is our horizontal shift. But what does the a tell us? Well, if a is between 0 and 1, that means it's going to be wide. But what if a is greater than 1? What's the opposite of wide?
Skinny.
Skinny, narrow, whatever the politically correct term you want to use. Okay? What if What if A is negative? That means it's going in the opposite what?
Direction.
Opposite direction of the parent graph. So if you don't know those parent graphs, you're going to be SOL. That's why those parent graphs are so important in 109. So now let's take our 2 to the x, since we're talking about exponentials. We did f of x, or y, hold your pinky up and say f of x. Y is equal to 2 to the x. We said that was a basic model. And then we did y is equal 2 to the x minus 2, which means a horizontal shift of 2 to the what? To the right. And then we did y is equal to 2 to the x minus 2, and then plus 7. So that's a vertical shift. But what if I change that 2 to 1/2? If I said in blue, if I change this to y is equal to 1/2 to the x power, what would that graph do? Instead of going like this, it would what? It would shallow out and go like that. It would stretch it, make it wider. Everybody with me? Make it wider, because you're stretching or compressing with the y-axis or stretching with the what? The x-axis. All this should be reviewed. So I want you to graph y is equal to 1/2, to the x power. Graph y is equal to 1/2 to the x power. So that'd be 1/2 parentheses to the x power, and watch what it does. These are all calculator drills you need to be doing at home, not during your homework. You need to just be playing with your calculator and learn these parent graphs and learn the vertical and horizontal shifts. You can do that with your calculator. So I'm going to go back to my calculator, and I'm going to type in y. Well, I'm going to take out the first 2 because we don't need to compare those. So I'm going to take that one out. And I'm going to take that one out. And I'm just going to graph this one in dark color. And it's going to be parentheses, don't use the keyboard, parentheses 1 divided by 2, parentheses raised to the x power. And it's going to be pulled along the x-axis like a rubber band, and then it's going to be pushed like a balloon between your hands. It's going to be pushed along, so it's going to make it wider. So let's see what happens. There's our first one. And there's our second one. And you see it's starting to, did I happen negative?
Mine's doing that too. I was just about to ask.
Okay, I know, the inverse. I'm sorry, it's the inverse. I'm sorry. It's the inverse. When you have the 1/2, that's an inverse. The 2 has to be up in here. My bad. I just screwed up. Let me redo that. Change that to 1/2. I'm changing it to 2 to the 1/2 x. I got the cart before the horse. Y'all can hold it against me, okay? So change that to 2. Change this to 2. Delete, 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 delete. Insert 2. And change this parentheses to the what? 1/2 power. There we go. My bad. 1 divided by 2, close parentheses, to the x power. That should do it right there. Now we can do graph. That should be the same graph. Okay, now I'm totally done messed up.
I think you got to put the parentheses. So.
Some of y'all may see what I've done. It should be 2. I'm going to have to put 2 sets of parentheses. Hold on. You got to learn how to use your calculator, which I haven't. So now change that. That should work. 2 to the 1/2 x power. That should work. There we go. Now look what it's doing. See? It's stretching it along the x-axis, or think of it like a balloon, and you put it between two hands, and you're squishing it. What's it going to do if you take a balloon filled with air, and you push on it like this? What's it going to do? It's going to get wider. Same thing if you take a balloon and pull on it this way, it's going to get wider. And that's what the 1/2 does. Now what if I change the 1/2 to a 5? What's it going to do compared to the first line parent graph? Is it going to put it right here? Or is it going to put it out here? Well, this made it wider, so what's the 5 going to do? It's going to make it skinnier. So let's put in a 5 and watch what it does. And like I said, I'm not trying to be a jerk or anything, but this is what everybody should know. I'm going over it because Miss Shuttleworth didn't listen in class, so half the time she's passed out, she didn't listen, so I'm having to go over it for her. Right, Miss Shuttleworth? Yeah, she didn't say. That's the first thing. That's the first thing about getting cured is accepting, admitting that you have a problem. She won't admit it. So, graph, look at there. It's going to go before. It's going to be to the left eventually, sometime in the near future. Okay, there it is. See it? See it right to the right of the, you only see like 2 dots. See, I made them believe they left. Why did they leave? Where are they going? Where are they going? All right, so let me change that line. Let's change that line. You can't see it because it's dotted. Let's change it to just a regular line. And you're going to have to watch it in sequence. Everybody with me? Okay, here's zippers, so that means a convulsion. Okay, so that one's going to be wider because of the 1/2, and then the other one's going to be right beside the y-axis.
Equal.
There it is. See it? Now, what happened there? When A is greater than 1, what happens to the balloon on the x-axis? It's pushing this way, and what's that make it? It makes it elongated along the y-axis. Or I'm stretching it along the y-axis, and it makes it elongated on the y-axis. Okay, let me ask you a question. Now, I'm not asking my 109 people, but I know I didn't have any of y'all, right? Okay? You know what I'm talking about with this, okay? From 109 or previous algebras?
Previous algebra.
What about you?
Catching on.
Catching on.
Previous algebra.
Previous algebras.
109.
You did get it in 109. Good. How about y'all three?
I've already had it.
Huh?
I got it.
Oh, I mean you.
I got a 109.
109? So there are some 109 teachers that teach this. What'd you get it in?
I got it in 109 too.
109? How about you? Okay, you have to. How about in, I just want to make sure everybody's got, okay, beside Miss Shuttleworth, go around the room. Black shirt. What's your name?
Me?
Last name?
Addison.
Okay, Mr. Addison, go. Well, have you seen this before? Where at?
Previous algebras.
Previous algebras?
The same.
Same?
I've never
109 or previous algebras?
previous algebra, we'll go with that.
Okay. What about the next one?
109.
109?
Algebra.
Algebras?
Algebra.
Algebra?
Yeah, previous classes.
Previous algebras?
I learned it in 109 too.
Okay, easily. Start with Miss Youssef because you're just going to sit there and stare at each other.
Previous.
Previous algebras? No 109? You didn't get it in 109?
I don't remember what I learned in 109.
Okay,
I
that's
took it a
pretty
really
bad.
long
Yeah.
time ago. Sorry.
Is that because of the teacher or because of you? Which one is it?
No, I took it like 4 years ago, so I just don't remember
Okay,
everything.
all right. Okay, next. Go around the room.
I saw it last in Algebra 2.
Algebra 2. What is next?
Previous algebras.
Previous algebras. Next. You had me.
Previous algebra.
You had me. Did all three of you have me?
He did. I didn't.
Okay, what about you? Where did you see it?
Previous algebra.
Okay, what about Oconee?
Oh, I had you last semester.
Okay, yeah, that's right. because there was 3 people. I think there was 2 or 3. The whole point is, some of you are a little bit rusty on it, right? So you need to get back to doing it. Now, how's a good way to do it? And I know some of y'all are going into convulsions, so you need to pass this around. Put the date on it. 2 more. You already did it? Okay. So what time is 11? Okay, we got 8 minutes, so y'all don't need to go in convulsions for another 2 or 3 minutes. Everybody with me? So no more convulsions until at least 2 or 3 minutes. All right, so what you need to do is this. Go home tonight. Now, I ain't forgot about your questions, Miss Shuttleworth, but I want everybody to go through this and get used to these family of graphs before we get into these questions. Okay, Miss Shuttleworth?
Okay.
Okay, so I want you to go home. I want you to make up some problems. And if you make up one problem, I want you to make up 2 other problems. What does it mean? Okay, let's do a quadratic. F of x is equal to, and I'm going to put x plus 3 quantity squared. And then I'm going to go over here and I'm going to do x, I'm sorry, put x squared first. Okay? Put x squared, and then over here put x plus 2 squared, and then over here put x plus 2 squared minus 6. And graph all 3 of those and watch what happens. And then I want you to do, just pick a x cubed. F of x is equal to x cubed. And then go over here and put x plus 3, or x minus 3. Let's do x minus 3. X minus 3 cubed. And then go over here and do x minus 3 cubed plus 2. And then I want you to go over here and do, let's go ahead, and you can do all the family graphs. There's 8 or 10 different graphs. You can play with this. Okay? Let's do an absolute value. F of x is equal to absolute value of x. Absolute value of x minus 6. Oops, doesn't have a square here. Absolute value of x minus 6 plus 4. And you graph those 3. And then move it into the logarithms. F of x is equal to the log of x. Log of x plus 3. Log of x plus 3 minus 4. And graph those 3. And then move it into the what? The exponentials. F of x is equal to 2 to the x. F of x is equal to 2 to the x minus 4. And f of x, f of x is equal to 2 to the x minus 4 plus 6. The whole point is you need to knock the cobwebs loose on these vertical and horizontal shifts. There's something else you need to do. Somewhere in your graphing, put a 2 here, so 2 to the x squared and 1/2 x squared. Here you need to put in 2 to the x to the third and 1/4 x to the third. Okay, you need to watch and see what this, I'm just trying to knock some cobwebs loose. Here, 4 absolute value of x and 1/3 absolute value of x. This one's going to make it skinnier. This one's going to make it what? We're going to make it wider. All of these are going to make it skinnier and wider. Same thing with logarithm. 4 log of x versus 1/8 log of x. This one's going to make it skinnier, which this is the regular, or sorry, log is, yeah, I think, and it's going to make it skinnier, or it's going to make it what? Lighter. Same thing with 2 to the x. You'd make it 2 to the 1/2 x, so that would be, or 2 to the 5x, or 2 to the 1/2 x. It's going to make it skinnier or wider. Now, all of this can be done on your calculators. And in the same time, you can be knocking the cobwebs loose with the calculators too. Okay? So I don't want anybody doing any homework tonight. All I want you doing tonight is playing on your calculators. I want you to, and watch what these vertical and horizontal shifts do, okay? If you want to, well, I don't even know where the family of graphs is in the 109, but last semester I did the 109. You can go back to my videos on 109, and you can actually see where I go through all this stuff, okay? All right, now, how many people are at the Pendleton campus? Somebody count.
And
Well, somebody's missing, so I'm going to have to take the roll. Anderson, y'all can leave, since y'all already did y'all. All right, hold on, guys. What time is it? I'll make sure y'all don't go into convulsions. Somebody give me the time. Okay, I got 2 minutes. So y'all Pendleton, you don't need to go into convulsions. All right, Bale.
Here.
Bale,
Here.
are you there?
Here.
Okay, speak up. Thank you. Bonaparte.
he's not here.
Okay. Childs.
Here.
Becky.
Here.
Dix.
Here.
SD.
Here.
Amy.
She's not here.
Amy.
She's not here.
Okay, that's 2. I'll go on down. Momin.
Here.
Novak.
Here.
Scott.
Here.
Butler. Butler. Shuttleworth is there. And Borg.
Here.
Borgie. Okay. All right, y'all get out of here. How many people we got in Easley?
Everyone.
There's 8 people there?
Over.
Let me call them because I've got 8 on the roll. Wait a minute.
There's
Okay, Shuttleworth, that's 1. Okay, let me do Bixler.
Here.
Harvey.
Here.
Hollingsworth.
Here.
Martin.
Here.
Carey.
Here.
Wilson.
Here, sir.
And Miss Youssef.
Here.
Okay, and Mr. Speed.
Yes.
Okay, have a good day. If you need anything, holler. Work on those calculators. Okay?
All right. Are we supposed to hang up?
Yeah, just hang up.